students, in the few tutorials we discussed on continuity and differentiability of functions. Now we are discussing differentiation. This is actually the previous year continuation, but again we are starting because it is the main chapter of class 12 standard. So a function f of x, this is a real valued function, this is a real valued function. Okay, this real valued function is a differentiable. It is a differentiable at a point, say x is equal to a, and this a belongs to the set of real numbers. Okay, and this is differentiable when you find that its LHD is equal to RHD. LHD is equal to RHD means left hand derivative is equal to right hand derivative at the given point x is equal to a. Now what is LHD? LHD means limit h tends to 0 f of a minus h minus f of a whole divided by minus h. This is equal to limit h tends to 0 f of a plus h minus f of a whole divided by h. If these two are equal, not only equal, they should exist. Okay, this should exist, this one also exist. If you find that these two limits exist and they are equal, then you can say that the function, the given function f of x is differentiable at the given point x is equal to a. Okay, in the last tutorial we also discussed on another important theme, that if a function is differentiable, suppose this is differentiable, okay, so at some point say x is equal to a, then this function is continuous. Okay, the function is continuous, but the reverse is not always true. This is not always true. Okay, so we do not again discuss this one because this will be the repetition. You just see the tutorial that is given in the description. Now we shall find some important formulae that you should need in 12th standard. So we one by one discuss this, and you should write all of them in your copy so that the next coming problems will be easier to you to understand. The first formula is derivative of a constant, any constant, ddx of a constant is equal to 0. You know this one, it is actually taken from class 11 standard. Again it is repeated here. Every time it will be repeated when you study differential calculus. Derivative of x to the power n is equal to nx to the power n minus 1. This is also from taken from class 11 standard. ddx of sine of x is equal to cos of x. Okay, next ddx of cos of x is equal to minus sine of x. Next ddx of 10x is equal to 6 square x. ddx of cosec x is equal to minus cosec x cot x. Next ddx of sec x is equal to sec x into 10x. Next ddx of cot of x is equal to minus cosec square x. Okay, write all of this. Next ddx of sine of mx, the angle is mx, it is equal to m cos of mx. Okay, in this way the others also. The last one I write ddx of cot of mx is equal to m minus m cosec square mx. Okay, next ddx of, suppose u and v are two functions of x, so ddx of u plus or minus v is equal to du dx plus or minus dv dx. Write all of this serial way. Next, ddx of uv, that is the product rule, is equal to u dv dx plus v du dx. Next, the quotient rule, ddx of u upon v. U and v both are the functions of x. Denominator is v square, v du dx minus u dv dx. Okay. Next, the chain rule. The chain rule. Let y is equal to function of t, say, and t is equal to g of x. G is another function. Then dy dx is equal to dy dt into dt dx. Okay, this is the chain rule. So you write all of these one by one. Now in the next page I am writing, okay, ddx of e to the power x exponential function, e to the power x, ddx of a to the power x, the base is a is any arbitrary number, a to the power x log of a base e. Next, ddx of e to the power mx is equal to m e to the power mx. Next, ddx of log of x base a is equal to 1 upon x log of a base e. Next, ddx of log of x base e is equal to 1 upon x. Now on this one I can write, actually it has come from the chain rule, so it should be discussed. Suppose we take an example, ddx of log of x base 10. So you can write it here, ddx of log of x base e into log of e base 10. Now log of e base 10 is a constant, so take it out, log of e base 10, and ddx of log of x base e, and you are getting here log of e base 10 whole into derivative of log x base e, that is equal to 1 upon x, so it is 1 upon x. So you can write 1 upon x log of 10 base e. Okay, in this way the derivative of log of x base a is equal to 1 upon x log of a base e. Okay. Next, the derivative of, now on the next page I write, you have to write all the formulae one by one, otherwise if you can remember all the formulae, then you can apply it, this formulae, in proper places correctly. Now inverse formulae. Okay, right. First formula, ddx of sine inverse x is equal to 1 upon root over 1 minus x square. Next, ddx of cos inverse x is equal to minus 1 upon root over 1 minus x square. Next, ddx of tan inverse x is equal to 1 upon 1 plus x square. Next, ddx of cot inverse x is equal to minus 1 upon 1 plus x square. Next, ddx of sec inverse x is equal to 1 upon modulus x into root over x square minus 1. Next, ddx of cosec inverse x is equal to minus 1 upon modulus x root over x square minus 1. Okay. Now there are some formulae in which you will find this x is replaced by other, say ddx of sin inverse of mx is equal to m upon root over 1 minus mx square, that is m square x square. In this way, the another formula, say ddx of log of mx, then what will you write? Base e. ddx of log of mx base e, you know this is 1 upon m of x into derivative of m of x. So you are getting 1 upon mx into m, such that m is cancelled, only 1 upon x. So derivative of log of mx base e is equal to 1 upon x. Again, derivative of log x base e is also 1 upon x. Okay, these are the main formulae of differentiation, but when you use this formulae, sometimes you should need some basic trigonometric formulae. I want to discuss all of them. Okay, so the first formula of trigonometry is 1 minus cos of x is equal to 2 sin square x upon 2. Next, 1 plus cos of x is equal to 2 cos square x upon 2. Next, sin of 3x is equal to 3 sin x minus 4 sin cube x. Next, cos of 3x is equal to 4 cos cube x minus 3 cos x. Next, sin of x is equal to 2 tan of x upon 2 divided by 1 plus tan square x upon 2. This is half angle. Next, cos of x is equal to 1 minus tan square x upon 2 divided by 1 plus tan square x upon 2. Next, tan of x is equal to 2 tan x upon 2 1 minus tan square x upon 2. Next, some formulae, these are also important, you should remember these. These are taken from inverse trigonometry. Tan inverse x plus tan inverse of y is equal to tan inverse x plus y upon 1 minus xy. Okay. Next, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. Like this, these are the formulae I have written. Like this, if it is given that tan inverse of 1 minus x upon 1 plus x, this is an example actually, if I take this example. So then what will you do? This is nothing but tan inverse of 1 minus x upon 1 plus 1 into x, so that you can write it tan inverse of 1 minus tan inverse of x. This is an example. Okay. Now we want to do some problems that will help you to understand this formulae properly or where to apply this formulae. First problem I want to take, say this problem is interesting. Y is equal to sine of 1 plus x square upon 1 minus x square. Okay, obviously you have to apply the chain rule. So dy dx, directly I do this one, ddx of sine of 1 plus x square upon 1 minus x square. Okay, so then what is the derivative of sine? That is cos, and its angle is 1 plus x square upon 1 minus x square. Now the next chain is ddx of 1 plus x square upon 1 minus x square. Okay, so cos of 1 plus x square upon 1 minus x square, and derivative of this one is 1 minus x square whole square, 1 minus x square as usual. The derivative of numerator will be only twice x, so write twice x minus 1 plus x square into derivative of the denominator, and the derivative of denominator is minus 2x, so write minus 2x. So that again you have to write cos of 1 plus x square, cos of 1 plus x square upon 1 minus x square into denominator is 1 minus x square whole square, and numerator multiply twice x minus twice x cubed minus plus twice x plus twice x cubed. Twice x cubed is cancelled, so 2x plus 2x is equal to 4x. So getting 4x upon 1 minus x square whole square into cos of 1 plus x square divided by 1 minus x square, hence the result. Next. Okay, another interesting problem, say if I take this one, y is equal to cos x plus sin x divided by cos x minus sin x, then show that dy dx is equal to sec square of x plus pi upon 4. How to show this one? What is given? Y is equal to this one. Okay, so you divide both numerator and denominator by cos of x. So cos x by cos x is equal to 1 plus sin x upon cos x is equal to tan of x whole divided by, similarly this will be 1 minus tan of x. You have to write it here, dividing both numerator and denominator by cos of x, so that you can write it here now. This 1 can be written tan of pi by 4 minus tan of x whole divided by 1 minus, you can think that this tan x is like this, 1 into tan of x. So because 1 into tan of x is again tan of x, so this one now can be replaced by tan of pi by 4. Okay, tan of pi by 4 into this is tan x as usual. So earlier we found this formula, tan a plus tan b divided by 1 minus tan a tan b, that is equal to tan of a plus b pi upon 4 plus x. Okay, so this is your y. Y is equal to tan of pi by 4 plus x. So now differentiate, dy dx is equal to ddx of tan of pi upon 4 plus x. Okay, so what is the derivative of tan? Tan means its derivative will be sec square of the angle pi upon 4 plus x into derivative of the angle pi upon 4 plus x. We are using the chain actually. So what is the derivative of pi upon 4 plus x? Derivative of pi upon 4 is 0. and derivative of x is equal to 1, so its derivative is only 1. So remaining part is only sec square pi upon 4 plus x. Is it your right side? Yes, sec square x plus pi upon 4. So the proof. Okay, next another problem I want to show. Okay, if y is equal to cos x minus sin x whole divided by cos x plus sin x, then prove that dy dx plus y square plus 1 is equal to 0. Okay, what is given? Y is equal to cos x minus sin x whole divided by cos x plus sin x. So again we want to divide both numerator and denominator by cos of x, so that you will get 1 minus tan of x whole divided by 1 plus tan of x. Okay, you have to write dividing both numerator and denominator by cos of x. Okay, this is cos of x. So that again in the same way you can write this one as tan of pi upon 4 minus tan of x whole divided by 1 plus, again you think that this tan x is multiplied by 1. That is a benefit if you multiply by 1, because this one can be replaced by 10 of pi upon 4 and into tan of x as usual. So there is a formula tan a minus tan of b whole divided by 1 plus tan a into tan b, that is equal to tan of a minus b. Here it is pi upon 4 minus x. Okay, it is your y. So differentiate both sides. Dy dx is equal to ddx of tan of pi upon 4 minus x. So differentiation of 10 means it's sec square and derivative sec square of angle pi upon 4 minus x into derivative of pi upon 4 minus x. We are using the chain rule. Now derivative of pi upon 4 is 0 and derivative of minus x is minus 1. So you are getting minus of sec square pi upon 4 minus x. Okay, now tell me what is the formula of tan square theta? From class 10th standard you got this one. You know the formula, 1 plus tan square theta is equal to sec square theta, isn't it? So minus sec square theta means minus 1 minus tan square theta. So it is your dy dx. It is your dy dx. So you can write dy dx is equal to minus 1 minus tan square angle is here pi upon 4 minus x. Okay, so take all of them on left side. Dy dx plus tan square pi upon 4 minus x plus 1 is equal to 0, or dy dx plus tan square pi upon 4 minus, what is tan of pi by 4 minus x? This is equal to y. So you replace it by y square plus 1 is equal to 0. Is it your proof? Yes, this is your proof, hence proved. Okay, in this way you practice at your home. I have given many more problems and discussed on the differentiation, also the many more formulae. You have to write all the formulae in your copy and practice at your home. Thank you. Have a nice day.